Hi, this video is going to help with 13.3 in Course 1. It is the circumcenter of a triangle and the incenter of a triangle. So let's look first at the circumcenter of a triangle and what that means. I'm actually going to switch papers. Okay, so here is a picture with the definition. So let's go through the definition. The circumcenter of a triangle is a point, so it's this point P, that is equidistant from the vertices. So here's the vertices, and your point P is equidistant from those vertices. To find it, you actually construct the perpendicular bisector of each side. So to find this one, you have to find the perpendicular bisector of each side, and where they meet is that point. And what's super cool about this is you can set your compass to the center and to one of your vertices, and you could draw the circle around that you can see on my example. So the thing about this one, though, this center could be in a couple different places. This is an acute triangle. If I happen to have a right triangle, the center would probably end up it would end up on one of the lines right on the triangle. If I had an obtuse, the center would be outside. So don't look for them all to look like this one. That just is the general pretty looking one that's easy to draw. So do know that the circumcenter can be outside of your triangle. Now let's construct a circumcenter just so you remember how it starts, and then we'll go through questions that you would have on it. Okay, so let's start with any triangle. I'll just make it acute triangle, and I'll make it sort of big here just so that we have plenty of room to construct this. So here is a acute triangle, and what we need is the perpendicular bisector of each side. So for perpendicular bisector, your compass needed to be set a little larger than halfway, and this is a little larger than halfway on all sides, so we're good. So I'm going to start with this bottom one, and I'm going to make an arc from both sides. And where those connect, remember, is how you found the perpendicular bisector. So this line, which I'm going to do in pencil, perpendicular is perpendicular to this AB, and it made these two equal. That's our perpendicular bisector. Now I'm going to turn this, and I am going to do the same thing to this side. So arcs, there we go. And where do those two cross? I think I have a red pen. I can do a red here, so they cross here and here. And that once again perpendicular, those two sides are equal. Oops, I lost my picture. See how that's perpendicular, and those two sides are equal. Last side, we're going to move over. We'll call the C up here. So we're going to look at BC here. I'm going to make my arcs again from each corner. So arc, and I kept it the same for all. It just makes it a little easier. Now these two are going to cross here and here. Let me see what other color I've got rocking. I have a blue highlighter. It should work. So let's see. Although it gave off like a ton at the beginning. Oh well. All right, so where do these three cross? You can see it right here, and that is your circumcenter of your triangle. What does that tell us? If I put my pencil there and I set this compass to one of the vertices, it better be equidistant from all three, and it is. That means I could draw a circle if I wanted, because they're all equidistant. If I did a good job at my constructions, they should go through exactly at the tips, which they do. So I guess I did okay. So constructing this one, it is from the bisectors, but what does it tell you? It then goes back and tells you, even though it's from the bisectors, so we constructed these three lines, right? That these distances are all the same. And you need to remember that for when you're doing problems about these type of questions. Okay, so that is what that is and how to draw it. Now let's look at a question on it. So let's see. What if I was just given 3 points, like, okay, 8, 3, and -3, 6, -6, and 8, -6. And you're told to find that point called the circumcenter. So you're looking for that point for the circumcenter, and you're just given, let me fix that a little. You're just given 3 points. Where I would start is to draw this on a piece of graph paper. I was like talking and trying to find where I've set my ruler. Okay, so call this the center here. It can be a little off. So I have enough room. All right, so what does this one look like? Let's graph 8, 3. 8, 3. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. There's 8, 3. And what? -3, -6. 1, 2, 3, -3. 1, 2, 3, 4, 5, 6. -3, -6. And what was the last one? 8, -6. So 8 is right here. 1, 2, 3, 4, 5, 6, 8. -6. So those are our 3 points. Okay, and then let's see this, because this is a little bit harder to figure out because you're talking about equations of lines, which confuses people a little bit because then they have to remember all that stuff from first semester. So let's look at what this looks like real quick. So a lot of the ones that they give you in Math Excel and that I'm doing here already have a vertical and horizontal line, which does make the problems a little easier. I'm looking for where's the center, where's the middle, and then I need to draw that line that's perpendicular. So how would I do that is I'm going to find halfway between these 2 points. Where's the midpoint? So let's start with which side did I start with? Oh, I don't know if it matters. Let's start with midway between on these bottom 2 points. So we would take, for halfway, we would take -3 and 8, and we would add them. And we divide it by 2, right? And that's halfway for the x's. And then for the y's, I would take the -6 and I would add it to the -6 and I divide it by 2. So this would equal 5 halves. What is 5 halves? Well, 2 goes into 5. What? Why did I put 3? Yeah, 2 goes into 5, not 3 times. I'm looking at, so anyway, it's 5 halves. And then -6 and -6 makes -12 halves, which I can reduce to -6. I was suddenly like, why did I write that down? I just wrote something down wrong on my notes. So if we go through this one, we know that halfway through this line is 5.5 -6. And we can see that, I mean, you probably could have counted over to see it and everything, that it's going to be at what, 2.5, -6 is about here. And you can see 1, 2, 3, 4, 5.5. And half, 1, 2, 3, 4, 5.5. So you can see it's exactly halfway there. Now I'm going to find the midpoint of this line over here, and I picked the vertical and horizontal because it's easier. So do that if you have those. So midway point between these two. So I would take 8 plus 8s for the x's, and I would divide that in half. And for the y's, I would take 3 plus -6 and divide that in half. That's going to give me 8 plus 8 is 16. Divided in half is 8. And then 3 minus 6 is -3 halves. And from here, so we know that over 8 and down -3.5, so that's 1.5 would be here. And you could see 1, 2, 3, 4.5, 1, 2, 3, 4.5, so we can see it's at the midpoint. Now let's draw the, because this is horizontal, it's super easy to say, okay, a vertical line through that point would meet at the perpendicular. Same idea this one, it would have to be a horizontal line to be that perpendicular. And it's right, so it's hitting on this line here, which we got from our original directions. You can't really see the point super well from here, but what would it be? Where would it be at? For this line here, it is vertical, so it has to just be the line x equals 2.5. And this line here has to be y equals -1.5. So where does it cross? Well, the x is at 2.5 or 3/2 or 5/2, excuse me. And then the y is at -3/2 or -1.5. So where do they cross? 2.5, -1.5. So 2.5, 1.5. There's where the circumcenter would be. So that's your answer, circumcenter. So you have to find the equation of these lines. It would be a lot harder if they weren't vertical or horizontal. So if I wanted to find what was perpendicular to this line, I would have to find the slope between those two. Then I would know that the slope of from this midpoint, the slope of the line that would be perpendicular would have to flip the fraction and change its sign. It's the negative reciprocal of the slope of this line. And you have to remember that negative reciprocal to find the actual perpendicular to this side. I know that, and then I could easily find the midpoint that it needs to go through, but to find that perpendicular would be a lot harder. And then to write the equation of the line, you would have a point, the midpoint, and you would have the slope, and you would have to then go through that process of writing an equation of a line. And we have done that. It'd be good review if they gave you a couple questions like that. I was wishing they would have. Okay, so the circumcenter. The next main idea is the incenter. Now the incenter, let me take that one off because otherwise you can see the shadow really good. So the incenter looks like this sort of. See how the circle's inside the triangle versus it was outside the triangle in the last one? The incenter of the triangle is a point where the angle bisectors cross, and it's always inside the triangle. This is where the perpendicular bisectors are equal distance from the point. Okay, it's always inside the triangle. That's different than the last one. And from that midpoint, is where this center is equal and equidistant and can draw that circle. So with this one, we start with an angle bisector. So the angle bisectors lead us to the perpendicular bisectors being equal. So the other one you started with angle or perpendicular bisectors. This one you start with angle bisectors. So if I was going to construct it, for the sake of time, I'm not going to do it. I'm going to just show you a picture of me doing it last time. What I would do is I would construct that perpendicular bisector, the bisector of each angle. See, I have those where it bisects each angle, and where they cross is that incenter. I would see this kind of mess if you were to construct an incenter, because I should see the line, the arcs that you use to construct those the angle bisector. Okay, so that's kind of the incenter. Let's look at a problem. Like, what would we see in terms of a problem? And these ones I think are a little easier than the where they go with the circumcenter. You might see a problem like, this is my second example. All right, so let's just call these ABC. And we'll say that this point, I'm going to guess, it's not going to be the exact point, but is, oops, maybe I should have done it this way. Yeah, it's like way off. All right, so what I'm guessing at right now is about where that halfway, or the bisector of that angle. Okay, oops. Okay, we'll go here instead. I guess it wasn't way off, but a little. All right, so mine gives us, all right, this one is bisecting this one, and this one is bisecting this one. So we know that that's kind of leaning towards the incenter. And then it might say something like, okay, so then from that point to here is 90 degrees. And from this point to here is 90 degrees. I think I said something wrong earlier when I was, I'll show you again and make sure we know it after this whole review. All right, so what if it says this is 4x plus 5, and they say that is 5x minus 3, like that. Well, what do we know? We don't know if this is the angle bisector of this third one to find the incenter, but we do know from here these two, and they give you problems like this where you have to know, all right, well, if two of these, then we know these two, because this is going to have to be the incenter, these two would have to be congruent because they go to the line and they're 90 degrees. What I was thinking of is I kept calling it a bisector. It doesn't bisect it. It goes perpendicular to the side, but doesn't necessarily bisect the side of it. And that's where I was like, ooh, I think I said that wrong. So it's a bisector of the angle to find this incenter, but when you draw it to the sides, it depends on the triangle on whether or not these two sides would be congruent to each other. Clearly not on this one. But we know those are equal. That's what we were given in our definition. So that would mean that 4x plus 5 has to equal 5x minus 3, so I can set them equal to each other to find x. So I'm going to minus the 4x over to the 5x to get 1x minus 3 equals 5, because these ones are gone. Then I'd add the 3, and I would get x is 8. So I could find those distances of those if it asked me, but we'll just find x for this one. So you could be given, I think it gives you quite a few problems that look similar to this one, and just know that these would have to be congruent at that, going out at the perpendicular. So again, incenter, circumcenter, and I would just keep a drawing of them close from the book or from maybe an example where you see the definitions to help you through this section.